Let's go to LeetCode 927, three equal parts. For this question, it gives us a binary array um, ARR, which is consists of only zero and ones. And we need to divide the array into three non-empty parts so that each part of them have the same binary value. So for these three parts, they cannot have overlap. And also, they need to make up the whole array. So for example, the first example one, right? We can divide this one into these three parts. And every part has binary value to be one, right? So it return this one's index and then this one's index. So that is 0, 3. Second one, we cannot have any separations. The third one, we can have mm, this is 0, this is 2. So return 0, 2. So for this question, actually, we know in order to have this array to be divided into three parts, right? For these three parts, we are find they are going to have the same suffix. For example, if you will have 1101, right? 1101, 1101. And also, before this suffix, it can have zero counts 0 to any number of zeros previous of that, right? So for example, we may have 3 0 here, right? We can have non-zeros here or have 2 zeros here, right? So this 0 can be any number. So what we're thinking about for this question is that the first thing is that we should have the one counts, total one counts should be divisible by 3, right? If we should divisible by 3, so that is first condition. And if we find it is divisible by 3, let's say, so for each part, the one count will be the, for example, let's say total divided by 3, right? Let's say this is k. So every part, it has a k number of ones. So what we're thinking about is that in theory we can put the three pointers at the initial of these three parts. The first one, the index of the first one. For example, we have ID 1, ID index 2, index 3, right? So we know for this index 3, it need to move to the end. For example, the end is n, length n, right? And then um, for this length, right, we should have index 2. We also move this the same length. For example, this is L. Index 1, it also need to move the same length L, right? And we can compare for this three index. Every time it move one index, we're trying to see whether these parts have the same shape, right? If any of them don't have same shape, for example, if this one is 0, the other is 1, then it's impossible for us to divide that into three parts. We just retain minus 1 array, right? Otherwise, um, when we when this index moving out of the range, this index 1, right? Index 1 will be I plus 1, and then index 2 will be j, right? So we have retain index 1 minus 1 and index 2. So let's um, implement our logic for these codes. Okay, so we're going to have n equals array dot length, and we're going to have int count equals 0, right? So for every v in array, we're going to have count should plus equal to v. So Um, so we should consider two corner case. If there is no ones in it, right? No ones in it, we can put, for example, the first one into zero, and the last one possibly to be one, right? Right. So we know to be two, right? I to be zero and j to be two, and as we know, the length is greater than three, right? Otherwise, because we want to have this index one to be the first one, and the index two to be the second, the first section, the start, right, of the first one of this section, this group, right, and index two is the second part, the first one. The index three, we put the third part, the first appearance of one, right? If there is no ones, uh, let's see, if count equals zero, right? That's a return new int, for example, zero and two, right? And the second thing is that if this count mod three equals to not equal to zero, right? Means it is not divisible by three, then we should return this minus one, right? And else what we do is that we have k equals count divided by 3. And we have index 1 equals minus 1. Index 2 equals minus 1. Index 3 equals minus 1, right? So what we do is that for int I equals to 0, I smaller than int I plus plus, right? And we'll have if array I equals 1, we'll have and we can have a count, right? We have another variable called, we use C in theory, it's called CT equals 0. So if this is 1, right, then we have CT should increase by 1, right? And we'll say if this is CT equals 1, then we have index 1 equals I. Mm, of course, you can also write this one, right? Write, for example, um, CT has equal to array I, right? And here, but you are right if you CT equals 1 and index 1 equals minus 1, right? Then we'll have index 1 equals I. Um, don't forget to do this condition, right? Because otherwise it's possible you have 1, 0. The I can be put in the zeros place, right? And we can also write if CT equals K plus 1 and the index 2 equals minus 1 less, then we'll set the index 2 to be I. And we'll write if CT equals 2 multiplied by K plus 1 and index 3 equals minus 1. We can have index 3 equals I, right? So now our condition is that we use a while loop while index 3 is smaller than n, right? So we'll have if array index 1 does not equal to array index 2, or we'll write array index 2 does not equal to array index 3. In that case, means the suffix does not match, right? Any of that doesn't match. If it doesn't match, then it's impossible for us to have the same binary number, right? Just return new int -1 -1, right? And we keep moving these three index. So in the end, we'll find the index 1 is I plus 1, index 2 is j, right? So we return new int index 1 -1 and index 2. The time complexity will be On, right? This is we traverse this array three times, and so it is On, and the space is constant. So we didn't see any actual spaces. We can also write Python code for this. So let's have n and total one, right? N equals length of array, and this will be sum of array. So let's see. Let's have the corner case if sum total equals 0, just return some 0, 2. And I will say if total mod 3 doesn't equal to 0, right? Just return -1, -1, right? Then we're going to have k equals total divided by 3. And then we'll have index 1 equals index 2 plus index 3 equals -1, right? And we can have another one count with 0. So what we do is that we're going to for I in range n, right? Let's say count should plus equal to array I. Then we'll have if count equals 1 and index 1 equals -1, right? Then we'll have index 1 equals I. Then we'll have if count equals k plus 1 and the index 2 equals -1. We're going to have index 2 equals I. And then we'll write if count equals 2 multiplied by k plus 1 and the index 3 equals -1. I have index 3 equals I. So we'll have a while loop while index 3 is smaller than n. I have if array index 1 does not equals to array index 2 or array index 2 does not equal to array index 3. In this case, we just return -1, -1, right? Otherwise, we're going to have index 1 should increase by 1. Index 2 should increase by 1. Index 3 should increase by 1, right? In the end, just return index 1 -1 and index 2.